Today is the first of two videos we're going to make covering right triangle trigonometry. You're going to need a calculator to do this lesson as well, and we'll talk about using a calculator successfully while we're introducing the concept to you. And so a lot of notes, and I left them here already written because that way I could talk about them and have the nice writing already there, or nice for me at least. All right. And so this is the little phrase or expression we're going to use to remember it. So it's SOHCAHTOA. SOHCAHTOA is how I remember right triangle trig. SOHCAHTOA. Now, it's also important that we have this triangle here, and I'll explain SOHCAHTOA. But from the triangle here, I have a right triangle. So a right angle, opposite of the right angle, the hypotenuse. I just shortened hypotenuse to HYP. Then I have two other angles, and so I have to work from one of those two angles. So that little theta sign just means, hey, we're working from this angle. So from this angle, this side over here is opposite, and this side down here is adjacent. Okay. If I quickly draw a different or a similar looking triangle, right, and call that theta now in that corner, this is still the hypotenuse, but now opposite would be down here, and adjacent would be over here. So it matters what angle you're talking about. Now, the S of the S stands for sine. Sine is the sin button on your calculator. You may have always wondered what that button does. It's for trigonometry. We'll use it quite a bit in this. You'll use it some algebra too, and then you really get into trig if you go down the road into pre-calc. Right? So S stands for sine of theta, of an angle. So the sine of an angle is opposite over hypotenuse. SOHCAHTOA. Right? So sine opposite hypotenuse. SOH. SOH. Ca. C stands for cosine, which is the cos or cos button on your calculator. Cosine of some angle equals adjacent over hypotenuse. CAH, cosine is adjacent over hypotenuse. Tangent, TOA is tangent. Tan button on your calculator. TOA, tangent is opposite over adjacent. And so these letters, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. This is just now going to break them down individually. Sine again is opposite over hypotenuse. And so now it matters what angle am I talking about. So if I'm talking about the sine of A, the opposite down here is the little a, and the hypotenuse is the C. But if I'm talking about angle B, then the opposite is this little b, and the hypotenuse is C. And so you have to know what angle you're talking about. And so if I make a right triangle here, and we say, hey, we're talking about this angle right here. That's the angle we're going to use. And let's say this is a 3, 4, 5 triangle. Right? And so I want to do the sine of angle A. Right? Well, sine is which means opposite over hypotenuse. Hypotenuse is always the one across from the 90. So that would be 4 over 5 in this case. All right, that's just called my trig ratio. We also still have cosine, ca. Again, it matters what angle you're talking about. So if you're talking about angle A, the adjacent is B because the opposite is down here. So that's the adjacent over the hypotenuse. If I'm talking about angle B, the adjacent is here because that's the opposite. So this is the adjacent. That's still the hypotenuse. And then tangent goes with TOA. T goes with O over A. So I would do, for tangent A, I would do opposite over adjacent. For tangent B, I would do opposite over adjacent. And so I'm going to write the ratios now. Let's remember, I have to use so, ka, toa. So sine goes with which one? Well, that goes with so. So where's angle J? Well, angle J is this angle right here. So if I come over here, this is the opposite, this is the hypotenuse, and this is the adjacent. And so sine of J equals OH. O is 5, H is 13. Cosine is ka. So cosine J is equal to cosine ka, A over H, 12 over 13. And then TOA goes with tangent. And so tangent of J equals tangent TOA. TOA equals opposite over adjacent. So 5 over 12. And so if it just asks you to, we're going to use a calculator and start solving this stuff more, but if it just asks you to set the ratio, this is just a basic understanding. And so that's how I'm going to set up my ratios. And so now grab a calculator, right? Whatever calculator you're going to use most often, and do a calculator check, right? Do a calculator check. Type in cosine 60, right? And you should get the answer. Your calculator is in the right mode if you get the answer 0.5. Otherwise, you need to change the mode your calculator is in. Now, if you have a good, nice calculator, like a graphing calculator from school, you'll be able to type in cosine first, then hit the number 60, and then hit enter equals. If you're using a little bit less fun calculator used for this stuff, would be like the iPhone calculator. And there you're going to have to type in 60 first, and then hit cosine. And again, you should get 0.5. If you got like negative 0.95 or something like that, your calculator is in radians. It's in the wrong mode, right? If it's a graphing calculator, hit the mode button somewhere in the top in the middle, mode, and then you'll see radian next to degree. Make sure you highlight the word degree. If it's a iPhone calculator, in the bottom left-hand corner, if it's coming up wrong in the bottom left corner, there'll be letters DEG. When you click that, it should start working correctly. Right? And so then these are the kind of problems we're going to solve. All right, so Matthias built a ramp so his sister could use the back door. The ramp is 12 feet. So this ramp right here is 12 feet. Now, it also makes a nice little right triangle with the ground. And he made the angle right here 4 degrees. And so there's 2 questions here. We're going to break them into parts. What is the horizontal distance from the ramp to the house? So this distance, the horizontal distance. So now I got to figure out, what am I using? Am I using so, ka, or toa? Well, I'm using this angle right here, 4 degrees. The 12 is the H. From this degree I'm using, from this 4 degrees right here, opposite would be all the way over here. So that would be the opposite. So this is the adjacent. Well, obviously I'm solving for x, so I'm going to use the a. And I need to use numbers in a math problem, so I'm using the h. So AH, which one of these three uses A and H? Ka uses A and H. So ka is cosine of 4 degrees, always of the angle, equals A over H. I times both sides by 12. And then see if you can do this in your calculator. Type in. Now, see, if I'm using my iPhone, I'm going to type in 4 first, and then I'm going to hit cosine button, And then I want to hit times 12. I'm using a nice like graphing calculator. I want to type it in just like it looks. And you should get 11.97. You can also use this problem to find the height. Same setup. I'm just trying to find this height now. I redrew this here. And so the height was across or opposite from the 4 degrees. The ramp is still 12. And so I'm using the opposite and the hypotenuse, which means I'm using so. And it's just because sometimes x will be on bottom, sometimes it's on top. It might be good to start writing it as a proportion. So sine of 4 over 1 equals x over 12. Cross multiply 1 times x is just x. 12 times sine of 4. Type that into a calculator. You should get 0.84. I use the little wavy lines because it's equivalent, not exact, to 0.84 feet. All right, if you're in class, that is our assignment. If you are just watching, I do appreciate it, and I will accept any feedback you have for me.